So in the first half of the video, you learned how to go from the name to the formula. So now we're going to learn how to go from the formula to the name. And like I said, this is actually much easier. So if you look and see that the formula is LIBR, all you have to do you even need to know what the formula, well, you know what the formulas of the cations and anions are. There they are, Li and Br. Does it matter that Li is +1 and Br is -1? No, because the name never indicates how many there are. So that's one thing about ionic formulas that's really kind of nice. The name is just, what's the name of the cation, what's the name of the anion, and that's it. It doesn't require you to figure out how many ions there are. So the name of this guy is simply lithium bromide. That's all it is to it. Lithium bromide. Name the cation, name the anion. So you're probably looking at this going, piece of cake, right? Do a couple more for practice. You're going to have to pull out the ion sheet again. K2CrO4. Hopefully you recognize potassium. That's my cation. If you go to your ion sheet and look, Cr2O7 is a polyatomic ion. It's called dichromate. Okay, dichromium, 2 chromiums, and the ATE is telling you it's got oxygens attached to it. Easy peasy, huh? All right, how about SrClO4-2? So Sr, you should know, strontium. Now, ClO4, you're going to have to look at your ion sheet if you haven't learned them yet, perchlorate. Again, does it matter that there are 2 perchlorate ions? Not as far as the name is concerned. So the only time you have to worry about numbers is when you're writing the formula to get the ion charges neutral. But to go from the formula to the name, much easier. Do one more. You know that's sodium, right? You know that's phosphorus, but it's not phosphorus ion, it's phosphide. IDE on the end. So, whoops, sodium phosphide. Okay? Now, there's a small percentage that are a little bit challenging, and those are the ones with Roman numerals. You do have to figure out which ion you're using, so the name has to be copper 1 or copper 2, whatever, or iron 2 or iron 3. So the Roman numeral has to be in the name just like it was in the name here, right? We did a bunch of examples with Roman numerals. The Roman numerals told you the charge. Well, now we got to do it backwards. We've got to use the formula to figure out what the charge is. So this is, again, where you might want to jot some notes down on that piece of notebook paper that you've got. So first one up, let's do Fe2CO3. Okay, so if you look at your ion sheet, you know that iron is either going to be Fe2 plus or Fe3 plus. Okay, so maybe I will jot that in here. I know that it's going to be either Fe plus 2 or it's going to be Fe plus 3. Okay, I don't know which one. I'm going to use the anion to figure it out. Okay, so here's the key. Start with the anion. When you have a substance that you know has a Roman numeral attached to it, and there's only 5 of them that you need to worry about, start with the anion. You know that carbonate is CO3 2-, or you will because you'll be using it enough and you'll memorize. So carbonate CO3 2-. So think about what my total negative charge is now. 1 is -2, but I've got 3 of them. So the total charge is -6. Well, we also know that the total positive charge better be +6. So I need +6 here. So I have 2 irons. What does each iron have to be in order to have a total charge of +6? It needs to be iron 3. So that's how I'm going to write it. I'm going to write iron 3 carbonate. Because that's what CO3 is. CO3 is carbonate. All right, let's do another one. SNO2. So you know this is oxide, O2 minus. Okay, you know you have 2 of them. So I must have a total negative charge of 4. Which means I better have a total positive charge of 4 as well. Since I only have one tin, what's the charge on the tin? It's got to be 4 plus. Plus 4. So what's the name of it? Tin 4 oxide. 2 more for practice, just to make sure you have this idea down. All right, lead. You look lead up, it can either be lead 2 or lead 4. Oops, those should be charges, not Roman numerals. Okay, I've got 2 chlorides. You know chloride is -1, so I have a total negative charge of 2. I need a total positive charge of 2, so this can't be lead 4, it must be lead 2 because I only have 1 lead. So lead 2 chloride. All right, last one. CuI. Pause and give it a shot. Okay, again, so I'm looking at iodide first. Iodide is -1. Hopefully you didn't have to look that up. Maybe the name, but not the charge, because it's a halogen, right? Iodine's one of the halogens. So copper can either be +1 or +2. Since I have a 1-to-1 ratio, it must be copper 1. So naming compounds is very easy for the most part. Probably 75–80% of them. Name the anion, name the cation, name the anion, bam, you're done. For those few where you have more than one possible charge, then you got to figure it out. So once again, to figure it out, you're going to start with the anion. Figure out what the total negative charge is based upon the charge of the anion and how many you have. And then use that to figure out what the cation charge needs to be, again, based upon how many of the cations you have. And then just name it. Roman numerals in the name, not Roman numerals in the formula. I don't know why I did that. +2, +4. Okay? You would never write Cu1 iodide. Well, that would be silly, but you would never write Pb2Cl2. You would never do that. Okay? Please don't do that. All right, so you've got a lot of opportunities to practice. Hopefully this helps get you started.